Welcome everybody. All right, we're in section 4.8 now, finally coming in of chapter 4, in which we've been studying about congruent triangles for the most part, and what we're going to look at here is performing congruence transformations, and the goal is that you will identify and describe translations, reflections, and rotations of figures. Okay, translations, reflections, and rotations of figures. Now, it turns out there's 4 types of transformations, ways of transforming one, triangle, square, rectangle, trapezoid, whatever you want to, transform. And 3 of those transformations I mentioned in the goal for this chapter that you'll be able to use those, and there's one more as well. One of those types of transformations is you can translate a figure. A second type of transformation is a reflection. A third is a rotation. And a fourth type of transformation is what's called a dilation. Now, we're talking about the first 3 in this lesson because we're looking at types of transformations in which, after the transformation, the figure that you get is congruent to the original figure. All right? These first 3 types of transformations are all a special kind of transformation called an isometry. Or you can say collectively they're isometries. And an isometry just means that measurements are preserved. Meaning that after the transformation, any distances or angle measures are the same as they were before the transformations. Now that's an idea we can talk about later on in chapter 9 because we're going to have an entire chapter on transformations once we get to there. Right now, let's get you familiar with translation, reflection, and rotation. Just giving you a surface area, or kind of a surface introductory to each one of these things. And translations. Now, translations are the same thing as slides. And so if I wanted to take this triangle and translate it, I'm just going to physically slide the thing over to the right so many units, down so many units, up so many units, to the left so many units. You just slide it in some direction. So let's say this is the result right here of translating that triangle. Now there's some vocabulary that I'm wanting to teach you right now, because there's no question in my mind that you understand that you just slide this figure over to make this one. But you got to know how to describe these transformations that we're doing as well. So let's talk. Now the translation with this direction, I'm just drawing an arrow. That's not an official way to describe the translation, but it works for what we did right here. What I want to tell you in terms of vocabulary, though, is this: that the figure that you perform a transformation to is something that's called a pre-image. All right, so whatever figure you start with is called the pre-image of the transformation. And then once you actually perform the translation or reflection, rotation, dilation, whatever it is, then the resulting figure is what's called the image. All right? And another way of thinking about the translation is that in order to translate this triangle, I translate each of its vertices the exact same distance and direction. And whenever you do that, you call the images of each vertex by a certain fashion. All right? So whenever I translate point A, then often we call that the resulting image A prime. And when I translate point B, well, then you get B prime for its image, and then C prime would be the image of point C. So pre-image, image. That's what I wanted to get across to you, and a little bit of notation that's associated with that. Let's look at a problem that you might actually see in your text based on translations, and you got to learn some more notation with this, otherwise it's very simple. The directions are telling you to copy figure ABCD, this quadrilateral here, and draw its image, there's that word we just learned, after the translation. And the translation is modeled by this statement right here, which is written in what's called coordinate notation. All right, now whenever you're trying to translate a figure, you've got to know the exact distance and direction to translate it. And on a coordinate plane, this coordinate notation is very effective for telling you how far and in which direction you're going to translate a figure. All right, the xy represents the coordinates of the preimage. And then this ordered pair over here, because that's still what it is, all right, you got parentheses and you got a comma. This is telling you what you do to the x coordinate of the preimage and to the y coordinate of the preimage in order to get the coordinates of the image. In other words, we would subtract 1 from the x coordinate of the preimage and add 3 to the y coordinate of the preimage in order to get the image after this translation. Hopefully that makes sense. If not, I think you'll get this. Basically, this is telling me that I'm going to move the figure 1 unit left, because that's what happens when you subtract 1 from the x coordinate, and I'm going to move it 3 units up. Now let's see that in action. In order to translate this quadrilateral, I'm going to translate each of the vertices by this amount. So I would take point A, go 1 left and 3 up. There's point A prime. And then in turn, well, it doesn't really matter if it's in turn, I would take each of the other 3 vertices for that quadrilateral and also translate them 1 unit left and 3 up. And I'll do 1 more of those with you and just put the rest in place. So point B, I would go 1 unit left and 3 units up to get to its image. So here is the image of point B. That's B prime. Go ahead and do that with all of the vertices of this figure. And thus the entire figure is translated. All right, now I mentioned this when I was telling you what types of transformations you have. I said that whenever you have translations, measurements is preserved. And I think you can see how this figure, the image, is congruent to the preimage, right? Okay, now I want to do 1 more of these just so I know that you're understanding this notation right here. In part B, what we're doing is we're going to add 2 to the x-coordinate, and we're not going to change the y-coordinate at all in order to translate this figure. Now, if you increase the x-coordinate by 2, that means you go 2 units to the right. If the y-coordinate doesn't change, you're not going to go up or down whatsoever. 2 units right, 0 up, down. And we will accomplish that again just by translating each of the vertices. Now I'm going back to the original figure here. So point A, it's going to get moved 2 units to the right. So will point B, so will point C, so will point D. And then we'll go ahead and make the quadrilateral by connecting. There's another translation for you. Simple stuff, right? All right, we still want to talk about reflections and rotations. And let's go with reflections next. Now, what I need you to understand about a reflection is that, first of all, you can also call it a flip. But second of all, whenever you're reflecting a figure, you have to reflect that figure in a certain line. You have to have a line of reflection. And you can have many lines of reflection. They can be slanted many different directions. I'm going to reflect this figure in a horizontal line. So let me make a line of reflection. And then the important thing to keep in mind whenever you have your line of reflection right here is that when you reflect the triangle in that line of reflection by reflecting each of its vertices, you want to make sure that the image of each of these vertices is the same distance away from the line of reflection as the preimage is. So for instance, you can see that P is 2 units above the line of reflection, so its image, P prime, would be 2 units below the line of reflection. Similarly, Q is 5 units above the line of reflection, so its image will be 5 units below. And then you can see how R would be 4 units below the line of reflection, or its image would be. And there you go. It ought to be pretty easy to tell that these 2 triangles are congruent because reflections also preserve measurements. Hey, that's how you reflect. Now, you're going to be asked to do some very simple things with reflections for this chapter, because again, we'll come back and do this in more detail in a later chapter. This is the type of thing you'll be asked to do with reflections. I've given you a figure on a coordinate plane, and I'm asking you to use a reflection in the y-axis in order to draw the rest of the figure. So, a reflection in the y-axis is a reflection in the vertical line. This is our line of reflection here. And we're still going to reflect it so that the images of each of these 4 points are equidistant from the line of reflection in comparison with their preimage. which is very simple to do. You can see that this point would reflect to there, this point would reflect to there, and these 2 points right here are on the line of reflection, and if ever a point is on the line of reflection, then its image is going to be in exactly the same place as it was. Okay, and here's the rest of that figure then. This is a pretty cool way to make some artwork, by the way, doing reflection type things. Very simple, right? Okay, one more thing to discuss here in this video, and that is rotations. Now, rotations we're going to do very little bit, only a very little with in section 4.8. Most of our work with them will be in chapter 9, but I do want to explain the concepts to you. Whenever you rotate a figure, there are 2 things you have to know. You have to know how far do you want to rotate it. In this case, I'm going to have us rotate a figure 90 degrees. We could rotate it 120 degrees or 250 degrees. You just have to have an amount or a size of the rotation. And then you also have to have a direction. Are you rotating counterclockwise or clockwise? And then finally, just like a reflection needs a line of reflection, a rotation needs a point that would be the center of the rotation. And this point P is going to be the point that we rotate this figure around. All right, 90 degrees counterclockwise. Now I'm going to show you the real bones of what we're doing right here. We again want to rotate the figure by rotating each of the vertices around this point. And the way I want to explain that to you is that you have to imagine there was a line connecting the center of rotation to the point that you want to rotate. And what we're going to do is we're going to rotate that segment 90 degrees counterclockwise. Now, if we rotate this 90 degrees counterclockwise, which is this direction, of course, that horizontal line would become a vertical line, right? And you see how this is 5 units long? So we're going to get a horizontal line that's 5 units long up here as well, like so, and that will be the image that we're looking for. So that's Z prime. Now the 90 degrees for the counterclockwise is right there. We went from here, 90 degrees that direction. And we're going to do that same thing with the other 2 points. It's just that the lines connecting P to each of those are not horizontal or vertical. So I'm just going to kind of show you where those end up. And later on, when it's more important, you'll learn exactly how to rotate those. And that's what this image would look like after the rotation. Now, just to want to illustrate one more thing to you to support what I said a moment ago. And I do that with this point X right here. You notice if I draw a line segment from the center of rotation to that point X, and I do the same from the center of rotation to the image of point X, you can see that there was a 90 degree angle there. So I did indeed rotate this 90 degrees counterclockwise. All right, that's reflections, rotations, and translations. That's all you need to know. I will see you in class, guys. Later.